In this section we will study LTE mobility. After completing this section, you will be able to explain the process of cell selection and reselection in LTE. Describe the purpose of tracking area update. Explain intra and inter-MME or serving gateway mobility while handling active traffic. In this module, we look at mobility support in LTE. In LTE, a UE could be in one of the two mobility states, idle and active. A UE is said to be in the idle mode when the UE is not actively exchanging traffic. A UE is said to be in active mode when it is actively exchanging traffic. When UE is in idle mode, it executes one of the three mobility-related procedures: cell selection, cell reselection and tracking area update. In the active mode, LTE needs to support two possibilities. One is the case where a UE moves from one cell to another cell with no change in MME, that is, intra-MME mobility. The second case is when a UE moves to a cell that requires a change in MME, that is, inter-MME mobility. We will walk through the scenarios for both idle and active modes in this module. For cell selection, the UE acquires system information block type 1 and read information about the PLMN ID of the network, cell barring status and minimum signal strength threshold. The UE first checks the PLMN ID. If this LTE cell supports a PLMN that the UE is allowed to use, the UE will continue on to check the cell barred status. There are several reasons a cell on the air might be barred from commercial use. If, for example, it is a test cell, we wouldn't want the UE to continue on this cell. If the cell barring status is okay, the UE will check the minimum signal strength threshold to learn if it passes the signal strength criteria for the cell. Some UEs at or near the cell edge can be blocked from trying to access the cell using minimum signal strength threshold. Of course, if any of these criteria fail, the UE will have to find another LTE cell. When cell selection is successful, the UE will read the information in SIB type 2 to get the parameters it requires for beginning uplink synchronization. While in the RRC idle state, if the serving cell is becoming weak, the UE will attempt to locate another cell. UE performs a cell reselection procedure if 1. Serving cell fails to satisfy cell selection criteria. 2. Neighboring cell is better serving cell. If the selected cell becomes too weak, or if another cell becomes stronger, the UE uses the cell reselection criteria to determine when and where to select a new serving cell. Cell reselection in RRC idle is similar to the system acquisition and cell selection discussed earlier. Once the UE finds a cell that is strong enough, it checks the cell's PLMN identity and barring status in SIB1. If the PLMN check passes, and if the cell is not barred, then the cell is suitable and the UE can select it. Otherwise, the UE moves on to the next cell and repeats the process. The UE will select a new serving cell if it no longer meets the cell selection threshold on the current serving cell and if a neighbor meets the cell reselection criteria. Whenever an idle UE selects a new cell as its serving cell, it may need to inform the network of its new location so it can be paged. In order to keep the number of location updates to a minimum, cells are grouped into tracking areas. Tracking area is a logical concept of an area where a user can move around without updating the MME. Each eNode broadcasts a special tracking area code, TAC, to indicate to which tracking area the eNode B belongs to, and the TAC is unique within a PLMN. Tracking area is identified by Tracking Area Identity, TAI. Tracking Area Identity, TAI, for each eNode B is broadcast by SIB1. Whenever the UE selects a cell with a different TAI than its previous serving cell, it has entered a new tracking area, and informs the network with a tracking area update, TAU. If two cells have the same TAI, then a TAU is not required. If an idle UE needs to be paged, the page request will be sent to all cells within the UE's last updated tracking area. When idle, a UE may be required to periodically send TAUs to the MME, when there hasn't been any traffic or mobility. The MME will use these TAUs as a keep alive for the UE's context. If the MME does not receive a TAU from an idle UE within an operator-defined interval, the MME may detach the UE and release all of its resources in the EPC. To send a TAU, the UE must establish RRC connectivity with the current cell. Once established, it will send a NAS tracking area update request. The tracking area update request not only includes the UE's identity, its GUTI, and the old and new TAIs, it also contains security-related information and the UE's list of its defined but dormant EPC bearers. The MME checks the integrity of the message, and may choose to authenticate the UE as well in order to avoid spoofing attacks. The MME then confirms that its list of EPC bearers matches the UE's. If there is a discrepancy, the MME will tear down any EPC bearers that are not active in the UE. The location update is acknowledged with a NAS tracking area update response message. If the UE is assigned a new GUTI, it must acknowledge with a tracking area update complete message before a timer, T3450, expires on the MME. Otherwise, the UE can release the RRC connection and return to RRC idle. Handover is used in mobile wireless systems to maintain connections as the UE moves between the coverage areas of different cells. Unlike 3G systems, LTE supports only hard handovers, meaning that previous connectivity with the serving cell is broken before the new connection is established with the neighboring, or target cell. Once the UE has set up an RRC connection, it is in the RRC connected state. The UE, following direction from the ENB, will measure the signal strength and quality of the serving cell and compare it with the signal strength and quality of the neighboring cells. When the UE determines that a measurement criteria has been met, it reports that information to the ENB, which may initiate handover of the UE. In LTE, handovers are UE-assisted but network-controlled, that is, UE provides measurements which help the eNode B to make handover decisions. We can more easily understand handover in LTE if we consider it in 3 stages: handover preparation, handover execution, and handover completion. In the preparation stage, the UE will send a measurement report to the ENB. When the measurement report is received, the ENB will make the decision to hand over to one of the neighbor cells, which we will now designate as the target. Using the X2 interface, the source ENB will collaborate with the target to determine if the target can accept the data sessions for the UE, and to establish a data forwarding tunnel for downlink data. The target will assign resources, like a new CRNTI and a dedicated preamble for uplink synchronization for the UE, and report those resources back to the source. Once the target ENB is ready, the execution phase begins. The serving ENB begins to forward any downlink packets to the target node B over the X2 data forwarding tunnel and tells the UE about the resources assigned by the target in an RRC connection reconfiguration message. Once the UE receives this message, it is no longer communicating with the serving cell, and will establish an RRC connection radio bearer with the target ENB. Note that any new packets arriving at the SGW are still sent to the serving ENB and then forwarded to the target. Depending upon the design of the ENB, the forwarded data may be buffered until the UE establishes the radio bearer with the target. The UE performs a handover, and now establishes an RRC connection with the target ENB. This establishes a radio bearer between the target ENB and the UE. Once the new radio bearer is in place with the target, the handover process can be completed. The target ENB, working through the MME, establishes an S1U bearer with the SGW, and maps it to the radio bearer. New packets arriving at the SGW are now sent directly to the target ENB. At this point, the old radio bearer and access bearer are released, and the data forwarding tunnel between the source and the target is removed, and any resources associated with the UE on the source ENB are deallocated. Here is what we discussed in this section. LTE networks use idle mode to save UE battery life and to save network resources. Idle mode is triggered by the ENB when it detects a period of inactivity with the UE. When idled, the EPC maintains bearers and UE context. UEs in idle mode must keep the network informed of their location via tracking area updates, and monitor for page messages. In the case of downlink data for an idle UE, the SGW will buffer the data. Any idle UEs not sending a tracking area update within a predefined period may be detached by the MME and all resources may be released. In this module we learn the following. Mobility in the RRC connected state is managed by the handover process. The ENB controls the measurement criteria for UEs and communicates this in the RRC connection reconfiguration message. ENBs collaborate on handovers using the X2 interface. One stage of handover has downlink packets being forwarded from the source ENB to the target ENB in a data forwarding tunnel. This completes the module. Click Next topic from navigation menu.